Hi, welcome to Block 5, Addition and Subtraction of Fractions, Lesson 7. I'll share my screen. So, in your previous lesson, you did a lot of work understanding equivalent fractions. In today's lesson, you're going to learn how to add and subtract fractions where denominators share a simple common multiple. You're going to see what that means exactly. Remember to click the like button for the video, subscribe to the channel, share the video with those you think can benefit, and click on the notification bell so that when new videos are released, you'll be notified. I would like you to pause the video and do the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've done the retrieval practice questions, here are the answers. So here you can see the denominators are all 6. So the denominator stays the same. You just simply add the numerators. And then you can change that to a mixed number by doing 25 divided by 6 will be 4 lots of 6. And then you'll be left with 1. The remainder 1, you write it as 1/6. Here you can see the denominators are still the same. So the denominator here will be 9. You simply do 7 subtract 4, which will be simplified to be 1/3. Here you have 8/11, 5 subtract 5/11, add 1/11. The denominators are all 11. So you can simply do 8 subtract 5, which is 3, and then you add 1, that should be 4. All right, next we have what is the lowest common multiple of 8 and 6? Lowest common multiple simply means you do the multiples. So you do the 8 times table, you do the 6 times table, and you pick the first number that you see in those times table. That's the lowest common multiple of both 8 and 6. Okay, let's do our learning. So Charlie eats 1/5 of the chocolate bar. Susie eats 3/10 of the chocolate bar. How much have they eaten altogether? Well, have a think. Well, if you take a look, you would see that the chocolate bar has been split into 10 equal parts. Now, when we say that we want to be adding fractions when their denominators share a common multiple, you can see that what is common to the 5 and the 10 is 10. So the common multiple of 5 and 10 is 10. So having a common denominator of 10 should be useful here. So that's for 1/5 because you can see that this has 5 columns or 5 groups of 2. And then if we want to shade 3/10, it will be 3 out of the chocolate bar. Now, if you add these, you will see that that is equivalent to 5/10, which is half when you simplify. Okay, here is a strip of paper. 2/5 of it will be shaded red and half will be shaded blue. The rest will be left white. What fraction will be left white? Well, you can begin to see, looking at their denominators, that our common multiple will be 10. Okay? So what we do is if we have this strip of paper and we shade 2/5, and we have another strip of paper and we shade half, but when we split it into 10, which is the common multiple, okay, the lowest common multiple of 5 and 2, you see that it becomes really easy. So we can see that that part, the width of these two parts is actually equivalent to 4 of the strip that is split into 10 equal parts. And then this width is equivalent or the same as 5 strips. So we actually have 1/10 left. Okay. All right. We're asked to use a bar model to answer these calculations. How do we go about it? Before we do that, I want you to have a think. What is the common multiple for 12 and 4? if you were to do the 4 times table and you were to do the 12 times table, what is the very first number you will see that is common to both of them? Of course, it's 12. So 12 is our common denominator. So that's why you see 12 being 12, this strip of paper being cut into 12 equal parts. Now we want to subtract a quarter. Now a quarter, can you see, is actually equivalent to 3 parts of that is split into 12 equal parts, which is the common denominator. Now, when that is removed, you would see that out of doing the calculation 712 minus a quarter now gives us 412. Okay, which if we simplify is 1/3. Okay, what about if we add them? If we add them, we'll get a different result, because note that although we have 712, 7 parts out of the 12 shaded, you can see that this part is actually equal to 3 of those equal parts. So when you add them to what you had already, you will have as your answer 1012, which if you simplify will be 5/6. What about this one? How do we use a number line to help us with calculations like this? Well, if you think about it, a half is actually halfway between 0 and 1. But 1/6, you can see that we have 1, 2, 3, 4, 5, 6. So 1/6 is just one part of that. Now, a half, remember how we used the number line to do fraction calculations? So a half simply means hopping to the half position. 1/6 means taking that off, okay, going back one way to the left. Now you can see that that means we're left with 2, 6. All right. So if you look at it in equivalent, if we look at equivalent fraction in terms of equivalent fraction, you can see that 3/6 is equivalent to a half. And we have done that because we want both of them to have the same denominator. So in this case, 3 minus 1 is simply 2/6, which you can obviously see when we did use the arrow to show or to model the problem and the solution. And you can clearly see why it is 1/3, because 2/6, have you noticed? It splits this into 3 equal parts, so it's 1/3 when we simplify it. It's now time for you to practice what you've learned. Pause the video and answer questions 1 and 2 in 3 minutes. Assuming you've paused the video and you've answered questions 1 and 2, here are the answers. So here you simply ask to write the lowest common multiple of the pairs of numbers. So by now, you should be practicing your times table. You should be really good with your times table to work with these, to find the answers to lowest common multiples of numbers. Next, you're asked to use the bar model to show 2/3 plus 1/6, which is equal to 4/6 plus 1/6. 2/3 simply means shading 2 out of that part. Okay, 2/3, you can see this splits this into, this line splits it into 3 equal parts. So this is 2/3. Then 1/6 is just one part out of the 6 parts shaded. And then you see that it's actually equal to 4/6 plus 1/6, which is 5/6. And you can see it here. And then next you says, using the same bar model, work out the answers to the calculations. All right, so these are the answers to the calculations. Something I want to show you quickly, which we'll look at even in our next slide as we carry on with our learning, is this. Okay, we could simply make the denominator 6 by multiplying by 2, and we'll multiply that by 2. So that will become 5 minus 2, which will give us 5 minus 2, which will give us 3/6. And of course, 3/6 will be a half. And this is the answer for the other ones. I don't want this video to be too long. Okay, pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. So here you are asked to match the number line to the calculations and complete the calculation. So these calculations shouldn't be a challenge to complete when we think about making the denominators equivalent. So really quickly, you can see that we have a common multiple of 4 between 2 and 4. So we can simply multiply that by 2, and whatever you do to the numerator, you have to the denominator, you have to do it to the numerator. So this is like saying 2 over 4 add 1 over 4, which is 3 over 4. Here, this one, you can make it 6 by multiplying that by 2. You multiply that numerator by 2 as well. So this becomes 4, 6 minus 1, 6, which is 3, 6. If you simplify 3, 6, you get a half. This one, you can make this 9. Remember, when you have the denominators being the same, it's easier to work with the fractions, so you have to multiply that by 3 as well. This is 6 ninths minus 1 ninth, which is 5 over 9. Here, you can see the common multiple to both numbers is 10, so we can multiply that by 2 to make it 10. We'll multiply that numerator by 2 as well, so we now have 810 minus 310, which will give us 510, and 510 can be simplified to be a half. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. So you can see you were simply asked to interpret the diagrams and to write what you believe are the fractions that satisfy this solution of the solution of the diagrams in their simplest form. And here are the answers. Okay, let's look at some new learning. If we want to, by now we've mastered how to use the bar model. We know how it works. So I'm not going to spend so much time deliberating on it. I'll just spend time talking about the method that we now know how to use. You can see that to multiply the numerator by and the denominator by 3 will make this denominator 12. So we have a common denominator, okay? Why? We have a common multiple of 12 between 4 and 12. So this time, it's easy to just do 7 add 3. The denominator will stay at 12 as 12. So we have 10 over 12, which is 5 over 6 when simplified. What about this one? Can you see the problem we have here? Have a think. What is the common multiple, or what number do you think should be common to the denominator? Of course, you can see it is 24. Now, you can see that to make 8 24, we're going to have to multiply by 3. That changes the fraction 3/8 to 9 over 24, because whatever you do to the denominator, you have to do it to the numerator. So now we know that the number in the denominator has to be 24, because we have conveniently changed the denominator of the other fraction to 24. So it becomes easy to deal with this problem by just thinking about or working with the numerators. So in this case, we're going to have to add 4 to get 13 over 24. Okay. And when you look at this, you would see that it is equivalent to 1/6. Okay. So if we want to rewrite the calculation, we could say 3/8 plus 1/6 is equal to 13 over 24. What about this one? What do we do? What is the common multiple that the numbers in the denominator share? Of course, the number is still 24. So if we want to change 1/6 such that the denominator is 24, we're going to have to multiply by 4. So I want you to have a think and to have a try to see what result you will get when you deal with this calculation. Okay. So if we do this, 24 is a common multiple of 6 and a multiple of 8. So we can change these to 24. So this has been multiplied by 4, same as this one. And that one to make it 24 by 3. And you have to do whatever you do to the denominator of a fraction, you have to do the same to the numerator. So now you have 4 add 13, which is 4 add 13, which is 17. 17 minus 9 will give you 8. So your answer is 8 over 24. And of course, you can simplify this if you want to. All right, it's now time to practice. Pause the video and answer questions 5 and 6 in 4 minutes. Assuming you've paused the video and you've answered questions 5 and 6, here are the answers. So here you're being asked to circle the calculation that is equivalent to 110 plus 115 plus 1/15. Now, you may be wondering why we have circled 1.5 over 15 plus 1 over 15. Well, you can see that all along there, the calculations, none of them are equivalent to the calculation, because in order to keep this the same, we have to use 1.5. So 1.5 times 10 is 15. And then remember, whatever you multiply the numerator by, the denominator by, you have to multiply the numerator by that number as well. But we wouldn't really need a decimal point in the numerator of a fraction. Next, we're asked to work out the calculations using equivalent fractions and then to give your answer in its simplest form. So I'll just discuss this quickly and then you can check the results for yourself. So this one, we need to make it 18. So that will be to multiply by 3 each time. So that will be 3 over 18, add 1 over 18, which will be 4 over 18, which if you simplify will be 2/9. Here, you need to multiply by 2. And then this will be 10 over 18, add 1 over 18, which will be 11 over 18. Notice, I must repeat what we're doing. We're only ever checking the denominator to see what common multiple we can use for them. This one, we're going to have 9, because the lowest common multiple of 3 and 9 is 9. So we'll multiply that by 3, or multiply that by 3. This will be 6/9 minus 2/9, which will be 4/9. And then here, this is going to have to be multiplied by 3. So this will now be 20 minus 9, okay? The denominator will be 21. So 20 minus 9 will be 11 over 21. This one, we need to multiply by 2. This one by 2. So this will be 9/20 plus 10/20, which will be 19/20. This one, might look a bit, challenging, but you can see that the lowest common multiple has to be 18. So for this, we have to change both of them. So we'll have to multiply that by 2, that one by 2, that one by 3, and that one by 3. So now we have this to be 8 over 18, add 3 over 18, which will give us 11 over 18. Here, the lowest common multiple for 10 and 4 has to be 20, okay? So you get to know these after you've worked, done some practice and you're really good with your times table or multiplication table. So this will be multiplied by 2. We have to multiply the numerator by 2 as well. This has to be multiplied by 5 and that one by 5. So now this becomes 14 over 20 minus 5 over 20, which will be 9 over 20. And of course, the other one, I'll leave you to check that yourself. Pause the video and answer questions 7, 8, and 9 in 5 minutes. Assuming you've paused the video and you've answered questions 7, 8, and 9, here are the answers. So for question 7, you were asked to work out the calculation to give your answers in the simplest form. You just need to make the denominators all equivalent. So this one should be multiplied by 2. So you need to multiply the numerator as well. Remember, the common multiple we can see is 36. Next, we'll multiply this by 6. So now we have 10 over 36, add 1 over 36, add 6 over 36. Now we have 17 over 36. And then this one, the common multiple will be, here it's, I think the common multiple will be 60. Okay, we can use 60. So we need to multiply this by 5, this by 2, and this by 12. Now we have 55 over 60 minus 22 over 60 minus 12 over 60. Okay, so 55 minus 22 will be 33. 33 minus 12 will be 7. Okay. And then, so 33 minus 12, sorry, no, 33 minus 12 is not 7, so that will be 1, and that will be 2. So we have 21 over 60. Sorry, that was my mistake. The answer should be 7 over 20, but I'm just, showing you how we got that. We need to divide this by 3, which will give us 7. And if we divide 60 by 3, will give us 20. Then for this one, we're asked to solve the equation. So remember how we solve equation. We eliminate or get rid of the thing that is preventing us from having the variable standing on its own and being expressed as equal to a number. And that thing is 2/3. The inverse of adding 2/3 to the equation is to subtract it. Okay, to get rid of that, we subtract, but we have to do it to the right-hand side as well. So now x is 7/12 minus 2/3. Now, the common multiple we can notice between 12 and 3 is 12. So we need to make this 12 by multiplying it by 4, and we need to multiply that by 4 as well. Now, our answer will be, we'll now have 7/12 minus 8/12. 7 minus 8 is -1. So we'll have -1/12. So our answer is -1/12. Okay, for question 9, you can see the answer here. You were given some cards. You were asked what's the smallest positive answer you can make using the cards in these calculations. So I don't want this video to be too long. So mark your work using the answers you can see there and celebrate your success. And that brings us to the end of our lesson. So what you've learned so far is you've been able to know how to add and subtract fractions that have a common multiple in the denominator. They share a common multiple. So it's really important you know that your common multiple is the lowest number that you can find. If you were to do the times table, the lowest common multiple is the lowest number you can find, the very first number you can find. If you were to do the times table of the two numbers that you find in the denominator. So for example, if I have in the denominator the number 3 and 9, of course the lowest common multiple of 3 and 9 is 9. So why? Because in the 9's times table, the first number 9 times 1 is 9. And in the 3 times table, the third number, if you do the 3 times table, is 9. So You do not need to change the fraction, the denominator of the one that has 9. You only need to change the one that has 3. But we also looked at cases where we had to change the denominator of both of the fractions that we're adding, or even when we're dealing with 3 fractions, because we found that the lowest common multiple of those numbers were higher than the individual numbers. So we had to change them by using some multiplicative relationships to make them have the same denominator. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.